This is section 2.1, the derivative and the tangent line problem. So in this section, we're going to introduce the definition of a derivative using limits. So a derivative helps you to find the slope of the tangent line at a point for any type of function. And there are two limit definitions we use. So f prime of a, so that little apostrophe denotes a derivative. So f prime of a is equal to the limit as x approaches a of f of x minus f of a over x minus a. Or the one that I typically would use is f prime of a equals the limit as h approaches 0 of f of a plus h minus f of a over h. So what you'll notice is that these two functions inside the limit, you'll notice that it looks a lot like the slope formula, because that's what we're actually doing. So looking here, so this first one on the left goes with our first limit function. So what happens is we're basically finding the slope between 2 points as x gets closer and closer and closer to a. And as we get infinitely closer to a, we're going to get to that tangent point, or that tangent line. Same thing as f of a and f of a plus h. As h gets smaller and smaller, so as we get closer and closer to a until h is basically 0, when we get that tangent line. So we're taking the limit, for the most part, of a slope. So we want to find the slopes of the tangent lines of the graph of f of x equals x squared plus 1 at 0, 1 and negative 1, 2. So let's first find f prime of x. So I'm going to use the h limit. So that's the limit as h approaches 0 of, going back up here, a plus h, or x plus h, minus f of a. So f of x plus h here is going to be x plus h squared plus 1 minus x squared plus 1 all over h. Notice that we can't use direct substitution, because if we do, we'd get dividing by 0, which doesn't work. So let's do the best that we can to see what cancels out. So we have the limit as h approaches 0. That x plus h squared becomes x squared plus 2x, plus 2xh. Plus h squared, and then we have that plus 1, and then distribute the negative minus x squared minus 1 all over h. You'll notice that things are going to start canceling out. So this x squared and this minus x squared, plus 1 and minus 1. And right now what we're left with is the limit as h approaches 0 of 2xh plus h squared over h. Direct substitution still doesn't work, but notice that we can take an h out of everything. So 2x plus h. And as h goes to 0, we're left with 2x. So the derivative is 2x. To find the slope at a point, we just plug in our numbers. So at 0, 1, it's 2 times the x value, which is 0, and at negative 1, 2, 2 times negative 1, which is negative 2. So notice that you'll see a bunch of different ways to signify a derivative. So the most common ones are going to be f prime of h, dy dx, and y prime. You'll also see d dx of f of x, or dxy. Again, these three are going to be the most common that you are going to see. The way this one is read, dy dx, it means the change in y with respect to x. Alright, so let's find the derivative of x cubed plus 2x. So we're going to use that limit definition again. Oops. So we're going to take the limit as h approaches 0 of f of x plus h minus f of x. So x plus h cubed plus 2 times x plus h minus x cubed plus 2x. Make sure that that goes in parentheses because we're subtracting it, all over h. So remember, x plus h cubed, we can do that over here, x plus h, and then we're going to have x squared plus 2xh plus h squared. So if we FOIL, we have an x cubed plus 2x squared h plus xh squared plus x squared h plus 2xh squared plus h cubed. See what we can simplify. I have an x squared h here and here. So the x cubed stays by itself. Plus 3x squared h plus 3xh squared plus h cubed. So the limit as h approaches 0 of x cubed plus 3x squared h plus 3xh squared plus h cubed, and then we have our plus 2x plus 2h, and then minus, ooh, running out of room, minus x cubed minus 2x all over h. All right, it's normal sometimes if you get a lot going on here. So let's see what we can cancel out. I see an x cubed and a minus x cubed. I see a plus 2x. Did I write plus 2x twice? I did. This should be a 2h. So 2x plus 2h. All right. So I have a plus 2x and a minus 2x. And notice everything that's left has an h. So I'm going to take away an h, 1h. This becomes 2. That h goes away. So we're left with the limit as h approaches 0 of 3x squared plus 3xh plus h squared plus 2. When h approaches 0, when we do direct substitution, this will go away and this will go away. And we're left that f prime of x equals 3x squared plus 2. Please notice that these might take a little bit longer than you want, but I promise I will show you a shortcut next time. All right, let's try something else. All right, let's find the derivative, f prime of x, for f of x equals the square root of x. All right, so we have our limit definition. The limit as h approaches 0 of the square root of x plus h minus the square root of x all over h. Notice that this one's going to be pretty hard to do any cancellation. So let's try multiplying by a conjugate. I see square roots, so multiplying by a conjugate couldn't hurt. So the square root of x plus h plus the square root of x. Don't bother on the bottom multiplying that out. So if we FOIL, this just becomes x plus h. And then we're going to have our inside and our outside are going to cancel out. And then we're going to have minus x. from our last. And then we have an h over times the square root of x plus h plus the square root of x. This x and this minus x go away. This h is going to cancel with this h, so we're just left with the limit as h approaches 0 of 1 over the square root of x plus h plus the square root of x. As the limit goes to 0, we get 1 over the square root of x plus the square root of x, which gives us 1 over 2 square roots of x. Like I said, I understand that it's going to be a little bit more challenging, but just do your best with it.